This next series of videos will cover the problem of overfitting and the solution of variable selection. So let's start with what is overfitting. Overfitting is when you add too many variables to a model. So you're trying to predict one thing and you just add as many predictors as you can come up with. It's like over-customizing your model. It's going to improve the in-sample performance, so your model is really getting to know all the specific variations in the training data. But when you go to look at performance out of sample in the test data, your performance is going to suffer. So that's a sure sign of overfitting. If you've got pretty good or really good performance in sample in the training data, but then you look at your errors in the test data and you see that there's really not stability here. Overfitting can adversely affect all types of models, linear regression, logistic regression, and anything else. It's specifically the condition of fitting the model you have really well to the training set and then expecting that to be to have really good performance outside. It would be like if you studied the practice exam as though it was going to be exactly the same test when you came to class to take that exam. So instead of generalizing and learning the concepts, you focused on the specifics, and then you get the new test in class and you don't do very well because you forgot to generalize those concepts. That's exactly what's happening here. The model is over-customized. It's not going to make good generalized predictions. So sure signs of overfitting include a really high R-squared. If it's super close to 1, like 1 or 0.99, then that's a very clear sign that you probably have overfit. You're also going to have an overfitting problem if you see that there's much worse performance in the test data when you look at the error distribution, either percentages for logistic regression or a histogram of the errors for a linear regression. If you have worse performance in the test set, poor stability, probably that's a situation where you have overfitting and you could consider removing some of the variables you're using as predictors. Fixing this problem of overfitting can improve stability, and sometimes it can fix it without losing any accuracy. Consider the possibility that having an R-squared of 0.7 might make for a better model than having an R-squared of 0.9, because it means you're reducing that over-customization and improving the stability. So now it's something you can rely on for maybe moderate to good performance out of sample. And your out of sample performance is what really matters. Can you trust this model to perform when it hasn't seen the conditions before? So what we're going to talk about in the remaining videos for this section is how to fix overfitting. What can I do to carefully select the variables that are the extras, the ones that should be removed?